and we have one presentation that is from Confidential 6G project, and Vera Stavroulaki from Wings will give us the presentation. So Vera, I can see you are starting the sharing. Okay, you may put it full screen. Thanks a lot. Floor is yours.
So thank you very much. Hello, everyone. I hope you can hear me okay and that my slides are showing properly. So thank you very much for this opportunity to present Confidential 6G. Confidential 6G, as you can see from the title, is on confidential computing and privacy preserving technologies for 6G. So I will start with a few basic facts about the project vision, and where we are in the work at the moment, and then also address a bit potential standardization topics and how we can maybe collaborate. Some key project facts. This is a Stream B0104 project. We are roughly in the middle of the project now, so we started in January 2023. We have 15 consortium partners from 8 EU member states. I am Vera Stavroulaki from Wings ICT Solutions. I'm the project coordinator, and the technical manager is Drasko Draskovic from Abstract Machines in France. And as you can see, we have various other industrial partners, SMEs, and academic and research organizations. So the project vision, obviously, we do need to ensure reliability, trust, and resilience in 6G infrastructures and 6G systems. So looking at beyond 5G or 6G systems as a deep integration of AI tools, hardware components and accelerators, computation and networking functions, as well as IoT and edge nodes. Obviously, we need to enhance security, privacy, and trust, and Confidential 6G emphasizes on privacy preservation and security of sensitive data by focusing on the protection of data, first of all, in use. And this is a relatively, let's say, new or unresolved issue with solutions emerging with confidential computing. In transit, where we are looking into enhancing communication protection with post-quantum cryptography, blockchain technologies, and secure data access control and traceability solutions. And also looking at the edge, where we are looking into post-quantum cryptographic approaches that are more appropriate also for constrained edge and IoT devices. And also in an effort to enhance privacy preservation and avoiding data movement from the edge, we are looking also into federated AI and ML. So in this sense, Confidential 6G bases its research on 3 pillars: post-quantum cryptography, which has to do with cryptographic enablers; confidential computing, where we are looking into collaborative AI ML, secure multi-party computation, and secure enclave abstractions; and confidential networking, which has to do also with post-quantum secure network protocols, secure data sharing, and so on. In To validate the different solutions that are developed in the project, there is some small-scale validation in 3 use cases. So the idea is really to test at least a subset of the solutions developed in the project in different scenarios. The first use case is titled Predictive Maintenance for Airline Consortia. This deals with the fact that when we look at maintenance processes, aviation companies have a lot of valuable data, and there are different organizations involved in the maintenance of aircrafts. But also these different organizations do not necessarily want to exchange this data, whereas on the other hand, having the data available by multiple companies could enable more precise maintenance and especially predictive maintenance. So this use case looks into specifically the implementation of secure and trackable data sharing between aviation companies, manufacturers, and other organizations involved in the maintenance of aircrafts. The idea here is to show how trustworthiness could be increased, especially also related to secure container orchestration for multi-party computation, and also potentially increasing efficiency of operations such as predictive maintenance with federated AI/ML over large data sets with multiple participating entities. The second use case is privacy-preserving confidential computing that looks into making it easier, let's say, to apply confidential computing, because a problem that exists is that in many cases these solutions are tightly coupled with specific hardware architectures. So here the idea is to leverage on different cryptographic enablers, confidential computing solutions, but also confidential networking developed within the project to make it easier, let's say, and a bit more automated to apply this type of solutions. So a key KPI here is to simplify, for example, deploying confidential virtual machines, enabling finer-grained remote attestation, handling configuration, and potentially also looking into tools such as Kubernetes for confidential containers. The third use case focuses on connected vehicles, mission-critical services, over-the-air updates for connected vehicles and vehicle-to-infrastructure communication. Here, the focus is more on leveraging, again, on cryptographic schemes, but also on federated learning in particular, to enhance privacy, security, and trust. Again, here, KPIs have to do with increasing the trustworthiness, also in the digital identities of the different vehicles and infrastructure elements involved, and also making privacy preserving communication a bit more efficient. Oh, sorry, I missed. My slides were not progressing appropriately. I hope it was still okay to follow. So now going a bit more into the details, let's say, of the three pillars. So first of all, in the confidential toolkit, or that is corresponding also to the cryptography pillar, one of the first objectives was to analyze security threats in the quantum area and incorporate them into a toolkit that can be utilized by different 6G applications. So here, the idea was to examine compatibility of different post-quantum technologies, keeping in mind also 6G security drivers like privacy-preserving computing, collaborative AI, and secure data sharing via blockchain, for example. So a key outcome has been what we call this post-quantum analysis report, which corresponds also to one of our first deliverables. And this is really trying to see how beyond 5G and 6G systems can be made resistant to quantum attacks and thus provide better long-term security. focusing on data confidentiality and privacy-preserving computation enablers. So then the next steps have to do with going deeper into the details of tools that can be used for confidential networking, looking into quantum safe transport layer security versions, confidential computation toolkit, which has to do more with the secure computation platform for different applications, and then looking into how blockchain could be customized for different applications. In terms of confidential computing, here a first step was to collect a set of requirements that are needed for privacy-preserving computation and secure collaborative artificial intelligence and machine learning, and define architectural blueprints that would guarantee secure and privacy-preserving characteristics of distributed computations in 6G networks. The next steps then have to do with looking a bit closer into different confidential computing enablers based on hardware extensions and components, such as trusted execution environments and GPU and FPGA accelerators for homomorphic encryption and secure multi-party computation, as well as looking into also combining those hardware approaches, potentially also with software cryptographic approaches such as fully homomorphic encryption. And then, as I mentioned also in the beginning, looking into enablers for privacy preserving computation on edge and constrained devices, looking then into potential solutions for fully homomorphic encryption that can be applied to such constrained devices, and leveraging also on trusted execution environments that are appropriate for embedded architectures. In terms of the confidential networking, here similarly, we looked at the requirements that are needed for post-quantum network security, focusing of course here a bit more on the networking part, so on the data communication and data sharing aspects. Again, we looked here at different architectural blueprints that would contribute to secure and confidential edge cloud communication and orchestration beyond 5G and 6G networks. We have also looked at secure and decentralized data sharing specifically, trying to combine different elements of blockchain, secure contracts, decentralized identifiers, and verifiable credentials. And next steps have to do really with prototyping some approaches for orchestration of confidential containers, and also, again, looking into aspects of federated AI ML to bring really this enhanced security and privacy at the edge. Here, focusing more on, as I said, on the data communication and data exchange. Just very briefly, indicatively, we can see on the top right a blueprint for the confidential networking, where the main components are what we call confidential orchestration, that has to do with the deployment and configuration of applications, algorithms, and data in different computing platforms in a manner that applications are kept isolated and confidential from the platform provider. Then there is a data sharing mechanism that is focusing more on the secure and decentralized data exchange while trying to ensure confidentiality, integrity, and traceability of the data. Then we have this focus on federated AI ML to protect data communication and data sharing. And also this security mechanism focusing more on post-quantum transport layer security. In the implementation of these mechanisms, as I mentioned also before, is relying on different kinds of available cryptographic techniques and tools, including both software and hardware. So as I mentioned already before, trusted execution environments, FPGAs, and in terms of software, looking at federated learning, homomorphic encryption, distributed ledger technologies, and so on. And at the bottom right, we see this high-level view of the confidential orchestration, where we are focusing on a container orchestration system that allows for automatic deployment, scaling, and management of containerized applications, trusted containers, where we are looking into hardware-secured containers, leveraging trusted execution environments integrated with these container orchestration solutions, and encrypted containers, where we are looking into software applications that can be secured using advanced cryptographic means, such as fully homomorphic cryptography. There's also orchestration intelligence that has to do with deploying and configuring these containerized applications, remote attestation, to authenticate hardware and software configuration to a remote party, and also secure services and communication between provider and host and between different confidential containers. In terms of standardization activities, we have had a few first steps, let's say. Between dissemination and standardization, we have a presentation of the project at the ETSI Security Conference that is taking place this week in Sofia Antipolis. And there have been also some contributions to some ISO working groups on cryptography, and more specifically then cryptography for finance. And there are also some efforts from our partner, Technical University of Eindhoven, that are mostly related until now to the cryptography part. So there have been some first, let's say, efforts, as I mentioned already. If we look at these key areas, mostly for now in the first area, on the quantum resistant cryptography, where the project is quite active and innovative, but further areas that could be also combined with the work of Hexa-X-II and other projects that have been presented today, could be, for example, in the area of AI, ML, and focusing on privacy preservation, if we look at it from the perspective of confidential 6G. Edge cloud continuum security. Again, edge cloud continuum, I think, is something relevant to most of the projects that we have seen today, but from confidential 6G, focusing more on the security aspects, and then also decentralized and blockchain-based networks as a means of enhancing confidential networking. Potential relevant standardization organizations, from our perspective already, okay, as I said, there have been some contributions mostly to ISO and to IETF, post-quantum cryptography working group. Maybe one relevant organization could be ETSI, where there are specific also committees and groups that have to do more with the security and cryptography, but also maybe looking into this ETSI MEC efforts could be something where we could all combine efforts, let's say. I already mentioned briefly a few of the KPIs when I was talking about the use cases, right? So confidential 6G, due to its nature, is maybe looking at KPIs and KVIs a bit in a different manner than other projects. But so on one hand, we have simplifying operations that have to do with confidential computing and confidential networking. if we look at the, let's say, 4 or 5 bullets here, but also we need to look into how these solutions affect energy consumption and computational resources. And this has to be taken into account also with respect to the scalability of the developed solutions. We hope that through the work of the project, data availability in general can be increased by increasing the trustworthiness of in different systems, infrastructures, and also parties that are participating, let's say, in a data exchange. So in closing, I think, okay, Confidential6G really looks into these enablers about cryptography, enhancing privacy preservation, so confidential computing and confidential networking. And this could potentially be combined with Hexa-X-II solutions or getting into the place of enablers that have already been identified, and maybe going a bit deeper from a Confidential6G perspective, and what is being done also in other projects. And similar to what also Efstathios was mentioning before, and I think other speakers, what would be interesting would be if we can find some common points, all these projects together, to have targeted efforts towards standardization bodies, because this would allow us, of course, to have greater impact. For this, we may need to synchronize also with relevant working group activities, right? Because there is an SNS working group on security, on architecture, and pre-standardization. So somehow combining all these efforts to have a greater impact and greater possibility of success, let's say, towards the different standardization bodies. Thank you very much. Apologies for the delay of 2 minutes. That was all from my side, and I'm available also offline for questions.
No problems. Thanks a lot, Vera, for your very interesting presentation.